Right. So very good morning to all. I welcome you all for today's metal forming session. A section working about Sanama because I think the number is very low. I think some students they went to TNP classes and some students they went for remedial classes. Okay, right. In what Sanama A section okay.
Yes, sir.
Okay, right. B section. B section students from input Sanama screen as well as audio and visual are okay. Anyone respond in B section? Pawan Kumar or Sultan. సుష్మిత తేజస్వి వినబడుతున్నామా వినబడుతుందా వినబడట్లేదా హలో స్క్రీన్ విజువల్ ఓకే మరి స్క్రీన్ కనబడుతుంది కదా రైట్ 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 సో in my earlier class just gone through the some again just because already like I am going through the revision of the unit 1. Okay, in the last class also just gone through the basic concepts related to the metal forming process. Mainly metal forming is a deformation process where by applying the forces and will when you're applying the forces and whenever the this like stress point like reaches to the yield point, then the permanent plastic deformation is going to start. So by considering this one, like we are introducing this particular concept in the metal forming process. Okay, there are different metal forming processes are there, like forging, rolling, drawing, extrusion, sheet metal forming, and different many more like process are there. So among them is forging, rolling, extrusion. These are the bulk deformation process. Okay, bulk deformation process. And mainly discuss like when coming to the simple this working principle of this particular farming. Okay, mainly like will place the workpiece okay in the die, and after that we'll apply the forces okay by means of the like hammers or by means of mechanical presses or by means of the hydraulic presses. Due to that the material will be deformed within the die. So during that deformation the material will flow within the die and it will occupy the that entire shape cross section of the particular die. Okay, and due to that repeated hammer blows or by squeezing force you can apply, by that it will the entire work material will force within the die and it will subjected to the plastic deformation. Due to that in that plastic deformation stage the material will flow within the die and it will attain the final shape and sizes will be obtained due to the particular principle. Okay, most of the cases maybe the like using of the nature of ports and using of equipment. Okay, that makes this metal forming process as a different types. Okay, that may be a rolling process. Okay, if we use some rolling equipment, then the metal forming process will be Right. Sorry for the interruption. There was a power failure. Due to that, I lost my network connection. Right. So just before that interruption, just I was explaining about the working the principle related to the metal forming process. So this metal forming process is also known as the metal working process or metal deformation process, where basically first we can with the just by the application of force or sometimes by heating the metal, and after that subsequent you will apply the forces. Due to that, the metal will get deformed within the die. So during the plastic deformation, the metal will close and occupies the entire that upper half and lower half of the die, and the desired product you can produce by that repeated hammer blows or by applying the squeezing action. So that based on that, like whatever the equipment and how you are and what temperatures you are using, okay, and based on that equipment, they are again metal forming process are classified into different types, rolling process, okay, metal rolling process, or forging process, extrusion process, and sheet metal operations like that. Okay, so and in the last class I explained about this one, working principle related to particular metal forming process, and also I gone through the simple equations related to the stress, that is engineering stress, true stress, true strain, and engineering strain. Because this particular deep metal deformation process are connected with the like uh, application of stresses. So when are applying the force over the unit area, then it will cause some stress in the material. So here the I discuss about particular equation related to the stress. Stress equal to load by area. That is the resistance offered by a per unit area of the material. So here, whenever you are applying the force over a material, the crystals inside that material, they will resist the applied force. That's why whenever that resistance force per unit area is equal to applied force by area, up to that particular then the metal will be not subjected to any deformation. Whenever this load by area is exceeds that R by A, then we can say that the material is subjected to the deformation. Maybe that deformation may be the elastic deformation or plastic deformation. So here, those things I discussed, and strain is the deformation per unit length, that is delta L by L. Delta L is change in length by L is the original length. And after that, I discussed about the stress strain curve, mainly like for the this particular stress strain curves. Okay, whatever stress strain, I explained two different stress strain curves. Like one is for engineering stress and engineering strain curve. So whatever this stress strain curve you are observing now on screen, that is related to the normal stress strain curve. Also, we will call it as the engineering stress and engineering strain curve. So where here we already know that engineering stress, we are going to consider the original cross-sectional area, but in the case of true stress, where we are going to consider the instantaneous area. So here, because this particular diagram, you can see that we are using a specimen, okay, of gauge length of L0. That is the L0 is the gauge length of the specimen. So once you are performing this, you are using this particular specimen and you are performing the testing, tensile testing over the particular specimen. then they subjected whatever this specimen due to the continuous application of load, then it starts start elongating. Okay. And these entire during that particular extension, the entire energy will be focused or concentrated on particular area, and that particular area it will get narrowed. Okay. And when compared to original cross section, that particular area will get reduced. Okay. The reduced cross section, that particular portion we'll call it as the necking. Okay. And beyond that, once this so in the stress strain curve, okay, basically after the yield, once the during your tensile testing, this one test in the UTM machine, the when you are applying the force, and due to that, whenever this on the stress strain curve, the point that reaches to this particular yield point. So when that there you can tell that the material is subjected to the plastic deformation. So after that, once it reaches the yield point, if even removing the load also, the deformation will not get vanished. Okay. So there is a permanent deformation. So, and after that, you are keep on increasing the load, and then this particular stress value reaches to the maximum stress point, and that particular related strength will call it as the ultimate tensile strength. Okay, there once this most of the cases, this particular specimen due to that ultimate tensile stress, due to the that increased amount of stress, it will form the necking. Okay. After that, even you are applying the less amount of force, then it may cause the fracture of the particular specimen. Okay, this is the related to this particular engineering stress and engineering strain curve, and also I clearly told that the true stress, okay, true stress and the true strain curve, it will be the different. It will not up to the ultimate point, the stress value is increasing, and after that, there is a reduction in the stress values. But in the case of true stress and true strain type of curve, where you can so observe this type of continuous increase in the stress value. So there will be continuous deformation, and once it reaches to the fracture point, then it will subjected to the breaking. So because we know that stress equal to load by area, load by area. So actually the stress strain curve, normal stress strain curve will take the original cross sectional area. That's why if there is a here we are continuously taking same area, so there is no even because there is directly it is related to the load value. So whenever we are increasing the load value, then there is an increase in the stress value. Okay. And if in the case of true stress and true strain, that is sigma t and epsilon t we are considering. Okay, then it will be the continuous. After that, it will be subject to the fracture point. Why? Because there we are going to consider the stress sigma t is equal to that is P by AI. Okay, where so we are at particular point, whatever the point your applied load, that particular point, what is the area, that instantaneous area are going to consider, because initially there is the area is larger one, and after that, once if you observe that the area at the necking point, there the area is get reduced. That's why once even there is a reduction in area. Okay, so reduction in area is inversely proportional to the stress values. That's why in our particular diagram, the stress values are continuously represented in the increasing manner. Why? Because we are considering the instantaneous area. Okay, that is the reason there is a continuous increase in the true stress values when you are indicating over the true stress and true strain type of curve. this the particular thing I explained in my earlier class. So after that, I explain about the engineering stress equation. That is whatever the load by whenever you are considering the like original cross section area, that is related to the like engineering stress, and after that, true stress is related to the like when you are considering the instantaneous area, then the related equation is the P by AI. So you can mention it is by P or F, no problem. Some textbook they will mention it as the load as F, and some textbook they will mention it as the P. AI is the instantaneous area, and engineering strain, that is Li is the what is the instant, that what is the extension. If it is a tensile test, then the specimen will get extended. That is the what is the that extension final length, that is Li, minus Lo is the what is the original length of the specimen by original length of the specimen. By that you can estimate the engineering strain. And true strain is is defined as instantaneous elongation per unit length. That particular I think related one is the true strain. That you can represent it by the formula Ln, that is natural log of Li by L naught. Li is the instantaneous length and L suffix O is the original length. These things I discussed in my earlier. So after that, I just discussed about the what is the relation between the engineering strain and true strain. So for that, first we taken the equation related to the true stress. Okay, and after that we taken the equation engineering stress. We know that that is the engineering stress equal to P by A0, and a true stress is P by AI. So after that, we know that true strain equation. The true strain is natural log of L by Li by L0, and engineering strain is given by the equation epsilon equal to Li minus. So just we return all the that engineering stress and true stress, true strain, and engineering strain equation. After that, equation 4 can reduce to the particular equation to 1 plus epsilon or epsilon plus 1 is equal to Li by L0. We just reduce that equation 4 to the 1 plus epsilon equal to Li by L0, and after that we just multiply the this particular equation both the sides, that is 1 plus epsilon uh, this Li by that is L0 original length by epsilon plus 1. This is the equation number 6. So this entire equation is both the side, left hand side and right hand side are multiplied with the natural log. Then we are writing this natural log of Li by L0, that is equal to natural log of 1 plus epsilon or epsilon plus 1. So after that we can just replacing this, because we know the general terminology, that is natural log of L by L0. Okay, that is equal to true strain. That's why we represent whatever the equation related to this particular natural log of Li by L0. In place of that, we just replaced the symbol of the true strain, okay, epsilon t, and that is equal to natural log of 1 plus epsilon. So this particular equation number 8, that is epsilon t is equal to natural log of 1 plus epsilon. So this particular equation, which will gives the relation between the true strain, that is epsilon t, and engineering strain, that is epsilon. So this is one of the important equation. Like even in my earlier classes, I discussed about some simple numerical problems where we can use this particular simple relation between the engineering strain and the true strain. That will be very useful in finding other different relations also. Okay, it's a very important relation. So after that, I discussed about the relation. What is the relation between the engineering stress and true stress? Mainly, like in this particular case, we assume that before the deformation and after the deformation, the volume remains same. So what is the volume formula? that is volume is equal to area multiplied with the length. That's why we taken the like A0 L0 are the original volume, AI Li is the like instantaneous volume. So and that is the we written the entire equation as the, we just equated that volumes, initial volume is equal to final volume, that equation written as the equation 9. After that we reduce that equation and develop the equation like a suffix I is equal to a suffix 0 by L0 by Li. So A0 is the original cross sectional area, AI is the instantaneous cross sectional area, L suffix 0 is the original length, and Li is the instantaneous length. So that was explained, and after that mainly like we know by just know the simple relations, so that sigma t equal to p by ai. Okay, we know that true stress equal to p by ai. A is the instantaneous area. From earlier equation, whatever the uh, developed relation ai equal to a0 l0 l by, that particular entire equation we are substituting in the place of ai, then we are rewriting that equation as the p by a0 multiplied with L suffix 0 by Li. Okay, and that final equation are getting as the P by A0 into Li by L, that is sigma t. So finally that entire this particular equation we are writing it as the our, because we from earlier relations we just writing this equation as the sigma t, and pi by a0 is the, it is sigma, that is engineering stress, multiply Li by L naught, we already got the relation, that is epsilon plus 1. Okay. This particular equation is the equation number 12, which will give the entire that particular relation between the true stress. Sigma t is the true stress, and sigma is the engineering stress. So this is also one of the important equation which will be very useful. Well, with some simple numericals related to the metal deformation, especially in like extrusion or different cases. We can use different formulas. So that true stress relation is sigma t is equal to and that is engineering stress. The relation between engineering stress and true stress is equal to sigma t is equal to sigma 1 plus epsilon, where epsilon equal to engineering strain and sigma equal to true stress, and sigma t is equal to, sorry, sigma t is equal to true stress and sigma is equal to engineering stress, and epsilon equal to the engineering strain. So this particular equation gives the relation between the engineering stress and true stress. The same thing explained here. So that this particular equation, sigma t is equal to sigma multiplied with the epsilon plus 1. So this particular equation number 12 gives the relation between the true stress, that is sigma t, and the engineering stress sigma. So these things were explained in my earlier class. So now I'll just cover the again revise this topic related to the because theory of plasticity. Okay. So in my earlier class was also clearly explained that this in the metal deformation processes mainly like the plastic deformation, like mainly the we are getting the final product due to the plastic deformation. Okay. So during this particular plastic deformation, mainly occurs due to the two different mechanisms. So one is slipping of one plane of atoms over a adjacent plane. Another one is the twinning mechanism. So the first mechanism is the slipping of one plane over the atoms over the adjacent plane. So due to the like uh, uh, developed shear stress, the at one particular plane, the uh, atoms will slide, okay, over the adjacent plane. So this particular thing will call it as the slipping of one plane of atoms over the adjacent planes. Okay, here you can observe that particular dotted line slipping that particular. Why we call it, because the slipping is going to occur in that particular plane. That's why we named it as the slipping plane. Okay. So due to the increased shear stress, it is causing the slipping of atoms over the adjacent planes. So that particular uh, mechanism is comes under the slipping of one plane of atoms over a adjacent plane. So in this particular, during that shear stress, okay, here whenever the shear stress is exceeds that b by a value, then there is a slipping of atoms will taken place. So here, what is the here the distance A is the spacing of the atomic planes. A is the spacing of atomic planes, and B is the atomic density. V is the atomic density. Like like always, the shear stress is directly proportional to the relation V by A. Always this shear stress is the directly proportional to the V by A. So as there is, if there is a increase in the V by A value, then it even increases the shear stress value. For example, relation the shear stress always the shear stress is directly proportional to P by A. Sorry, it is directly shear stress is, that is tau, is directly proportional to P by A. Because didn't have the digital, but that's why not visible. But where B is the atomic density and A is the spacing of atomic planes. So if due to the applied loads, the shear stress is like mainly develops whenever that V by A value increases. So if there are V by A ratio value is increases, then it increases the shear stress, and due to that it will cause the slipping of like atoms over the slipping plate. This is the how there is a during the plastic deformation, how the slipping mechanism is going to cause this plastic deformation. Okay. Next one is the twinning mechanism. One is the slipping, mainly the plastic theory of plastic plasticity, that is plastic deformation, mainly occurs due to the slipping of one plane of atoms over the other adjacent plane. Other mechanism is the plastic deformation may take place due to the twinning. So in during this twinning, what is going to happen is some portion of crystals they will form a mirror image. So because during that because you are applied a force over a material, due to that there is a movement of the crystals may get displaced Okay, and during that, a portion of crystals form a mirror image about a plane. Okay, so whatever the plane, okay, where it is go, like this developing this mirror image, that plane will call it as the plane of twinning, plane of twinning. So mainly, due to the increased force, there is a displacement of crystals, and they are displaced in such a way that they will some portion of crystals they will form a mirror image around a plane. So the plane around which the mirror image is going to develop, that particular plane we are calling it as the plane of twinning. So in this particular diagram, mainly uh, there is a deformation. You can observe the same mirror image. You can found that crystal arrangements are like this. They are arranged. They are in a like this. The same arrangement even you can find in the other portion of the like plane. So that particular thing will call it as the like twinning. So due to this particular mechanism also, there is a plastic deformation. One is the due to the like the slipping of one plane of atoms over adjacent plane. Okay, mainly there like there is a b by a ratio value exceeds that particular increases. Due to that, it will increase the shear stress. Due to that, there is a crystals will slide over the adjacent plane. That is the slipping of plane of atoms over the adjacent plane. Another mechanism is the this particular twinning mechanism, where about a plane of twinning, it forms a mirror image of the crystal. That particular due to this also, there is a plastic deformation is going to occur. So next one is already the next topic related to the recovery, recrystallization, and grain growth. Recovery, recrystallization, and grain growth. We already know that what is the recrystallization. Okay, and also I explained so many times about the effect of strain hardening or work hardening. Okay, so what is the strain hardening or work hardening is when there is an increase in the shear stress. So this increase in shear stress that causes the an increased overall strength of the material, which is known as the work hardening and strain hardening. So whatever the effect, so strain hardening or work hardening it is an effect due to the increase in the shear stress value. So whenever there is a shear stress increase that causing the overall increase in the strength of the metal, that particular concept is connected with this strain hardening. Strain hardening or work hardening is the effect of an increase in shear stress that causes an increase in the overall strength of the metal is known as the work hardening or strain hardening. This particular work hardening is mainly the concept that is mainly related to the strengthening of the metals. Okay, so there it is a very good. Even at the normal temperatures also, you can use this particular concept in increasing the strength of the metal. So whatever in automobile bodies and aircraft fuselages, so where by a concept of cold rolling process, you can increase the strength of that particular automobile bodies or other different components. Okay. So next concept is related to the recovery, recrystallization, and grain growth. Here, the recovery, nothing but recovers at mainly occurs. This recovery mainly occurs at the below recrystallization temperature. Recovery mainly occurs at the below the recrystallization temperature. During this, the stresses, whatever the like. like the internal stresses are there. Those stresses are relieved during this uh, recovery process, during maybe due to the temperatures or due to the adjacent regions in the particular metal. There may be, it may cause some development of residual stresses. So those stresses may get revealed by this particular recovery process. So mainly this recovery mainly occurs at below the recrystallization temperature of the metal. By this, the stresses in the highly deformed regions are relieved by this recovery process. So this is the stage one. That is the, so whatever the any residual stresses are there due to the adjacent planes or adjacent areas, that those stresses can be relieved by this particular, in this particular recovery zone. See the particular recovery zone, okay, like where it's going to occur mainly below the recrystallization temperature. Like grain sizes or how they are affecting the strength, ductility, and hardness, and what about the residual stresses that we are going to observe in this particular. So it's actually even clearly mentioning that in this particular recovery zone, so you are performing the recovery operation, so it will reduce the that amount of residual stresses, leftover stresses or locked in stresses are there. That locked in stresses will be relieved by this particular recovery process. Okay, and also like because here here you can see that the ductility property here this particular, the ductility will be less because initially it that material may have the residual stresses. Okay, and also that before that during the cold working, so this is the zone of cold working. So cold working, we further just I will give the concept of recrystallization. So recrystallization, the process in which it has a certain temperature range, new and strain-free grains are going to formed by replacing the older grains is called the recrystallization. So for every material at a certain temperature, like whenever heating that particular material to certain temperature range, then it will destroy the older grains, that is older crystals, and forming the new strain-free grains. They are going to forming by replacing the older grains. Then that particular temperature, we are going to call it as the recrystallization. So recrystallization, a process at which at a certain temperature range where new and strain-free grains are formed by replacing the older grains is called the recrystallization. Mainly, recrystallization decreases the density of dislocations. Okay, so due to that, it lowers the strength and raises the ductility of the material. Like if any metal, if consists of that, if the density of dislocation is high, then it will increase the like especially in a cold working or cold working zone, the density of dislocations are very high when compared to the recrystallization zone. Due to that, you can observe clearly that the strength of that particular material in the cold working zone, due to the increased dislocation, the strength and also hardness, strength and hardness are very high in this particular cold working zone. Okay, and because in the cold working, these there is a due to that uh, temperatures less than the recrystallization temperatures, and also you are mostly depending upon the huge amount of forces. Due to that, the grains get elongated and they get there is a deformation of the grains. Okay, and after that, in the recrystallization zone, it will destroy all this particular whatever the grains, deformed grains, whatever the there, that deformed grains will be destroyed, and it will form a small crystals. Okay, new crystals. So and also this one even at the at this particular range of temperature. Okay, it will form entirely new grains, and after that it starts the increase in the size of the grain. You can observe clearly from this particular zone the size of the grains are increasing slightly, and after that this particular when it reaches to the this particular grain growth zone, there you can observe clearly the grain sizes is continuously increasing. Okay, whenever there is a grain size is increasing, what it is going to see, like observe it clearly, it will improve the ductility property, and the surface you can observe the coarse, some rough textured surface you can observe, and also like the strength and hardness properties are reduced. These all things are like if there is increase in the ductility, then anyway it is its connected hardness and strength are get reduced. So due to the increase in the this particular grain growth, that is the like concept related to the this particular recovery, recrystallization, and grain growth. So once you are increasing the temperatures, okay, once you are increasing the temperatures, so the grain one particular zone, this particular recrystallization point, then it starts the increase in the grain sizes. Okay, if there is increase in the grain size, so that will affect to the there is ductility, that is the coarse grains always will have the good ductility, and but their strength values and these hardness values get reduced. Okay, okay, due to the increase. So that's why we can't during the farming process you don't have to go increase the temperature beyond that when like this grain growth zone. So whenever that metal, these particular grains are subjecting to the grain growth less than that, only you have to maintain the recrystallization temperatures. Due to that, it will maintain that strength and hardness. If there is an increase in the grain sizes, that will affect the strength and hardness. There is a reduction in the strength and hardness, and that but there is a good ductility. That's why, like, if any work materials, like you want to decrease its strength and hardness, that's why the people will prefer this annealing process. It is a heat treatment process. By performing annealing heat treatment process, you can reduce the strength and hardness of the metal. So that is the particular related recovery. Recovery is the occurs at below the recrystallization temperature of the metal. During this, the stresses in highly deformed regions are relieved. And recrystallization is nothing but the process in which at a certain temperature range new and strain-free grains are formed. Because why is strain-free? Because earlier before recrystallization, cold working is occurred. In the cold working, because the grains are get compressing, and these grains are having that strain within the adjacent grains. Due to that, by increasing the temperature, it is forming the new grains. Due to that, there is a the grains are strain free. Okay, so it is forming the new and strain free grains, and by replacing the older grains, that particular temperature we are calling it as the recrystallization temperature here. Okay, and especially you can avoid that water leftover stress, residual stresses will be get reduced by increasing the temperatures. Like during recovery, it is reducing, and after that, completely for increasing the temperature, these values get completely decreased. Okay, the leftover stresses will be locked stresses will be reduced due to the increase in the temperatures. You can observe that the residual stresses will get zero here in this particular. Once you are increase the temperature over the particular recrystallization temperature, completely it reveals the entire residual stresses. So that is about this particular recovery, recrystallization, and grain growth zone, where even at the end of the recrystallization zone, it starts the increase in the grain size. So whenever there is a like increase the grains size, there will be no proper bonding between these particular as side by side grains. Due to that, it will reduce the strength. There is a reduction in the hardness, but there is a improvement of the ductility. So that is the always these coarse grains are the reason for the low strength and low hardness and good ductility. If you want, then always you prefer the this increase in the grain size. So that is about the explanation regarding this particular recovery, recrystallization, and grain growth. So based on that, based on the recrystallization temperatures. So whenever your that working temperatures are below the recrystallization temperature, then the process will call it as the cold working or cold working, where the in even that recovery recrystallization, this graph also, that layer like simple diagram clearly explain that in the cold working zone, where due to the strain hardening effect, there is a increase in the strength and hardness of the material. Okay, mainly you with you want to improve the strength of the material, then the people will prefer this type of cold forming or cold working technique, where you have to use the temperatures below the recrystallization temperatures. Mainly, there are different cold working techniques are like squeezing, bending, drawing, and shearing. These are the different cold forming techniques. Mainly, cold working mainly causes the crystal grains to distort. Okay, because already I explained in earlier diagram also, there is a distortion of the grains during the cold working of nature. And also you can mainly observe that increasing that strain hardening effect we are going to observe in the cold working. So mainly when you are this plastic deformation of material is carried out at temperature below the recrystallization temperature, then the process is called as the cold working. The entire opposite one is the this hot working. So wherein when a plastic deformation of material is carried out at temperature above the recrystallization temperature, then the process performed on a metal are termed as the hot working. Entirely opposite one. When you are performing the plastic deformation of a material or metal, is carried out over a temperature above the recrystallization temperature, that particular process, they're calling it as the hot working. So in the most of the cases, the maximum temperature of hot working of metal is set 50 degrees below the melting point. Most of the cases, the maximum temperature of hot working of metal is said to be 50 degrees below its melting point. For example, for aluminium, the melting point is 660 degrees centigrade. So the maximum temperature of that particular hot working metal. So maximum temperature of hot working of metal, we can set it as the 610 degrees centigrade. Okay, that is one simple example. What is particular? There is one more division in between, one more working is there in between the if you are not maintaining this recrystallization, or if you are not maintaining the this particular hot work, cold working and hot working. So there is one of the terminology that is known as the warm working. There is a one other working that is in between the cold working and hot working, that is known as the warm working. WARM, warm working. Okay. So to differentiate all these processes, they given one simple terminology. Okay, we are having the in between the hot working and cold working, the middle one is related to the warm working. Warm working. So how we can differentiate this hot working, warm working, and cold working? So mainly this warm working, when the will people will prefer this one is whenever, like we already telling that during the cold working, due to the strain hardening effect, if the material strength is increased much more, then to reduce that strength, you can perform the warm working. Okay. Beyond that cold working or for hot working temperatures we are using, there it may develop some coarse grains once you are increasing a hot temperature. Beyond that, due to that, it may strength also get deviated. To avoid that one, the people are preferring this warm working. Due to that, there is a, without compromising the strength, means somehow the cold you can the strength of the particular material will be less than the cold working, but the entire strength is not get reduced if mainly the materials where over strength like is developed due to the strain hardening, that effect can reduce by this particular warm working process. Okay, and how we can differentiate this particular cold working, warm working, and hot working is, for that there is a one ratio is there. That ratio is the T by Tm. The ratio is the T by Tm. Just note down this one, T by Tm, where T is the this working temperature. T is the working temperature, where T is the working temperature, and T suffix M is the melting temperature. Working temperature, working temperature, and T suffix M is the melting temperature. Melting temperature. So we are going to use one ratio to differentiate this cold working, warm working, and hot working. That is the ratio is T by Tm. The ratio of T by Tm. That is, T is the working temperature and Tm. So this particular thing ratio, we are calling it as the homologous temperature. Homologous temperature. HOMO, homologous temperature. LOGOUS, homologous temperature. Homologous temperature. Homologous temperature, which is we are going to use to differentiate the cold working, warm working, and hot working. So what is homologous temperature? Homologous temperature is the ratio of T by Tm. That is, T is the where T is the working temperature and Tm is the melting temperature. So based on this T by Tm temperature, for example, if the like T by Tm temperature, T by Tm temperature, that is, this ratio value is less than, T by Tm is less than 0.3. If the T by Tm value is less than 0.3, then that then that particular we have to, the process can have to perform is the cold working. Cold working. Cold working. So we have to perform the cold working. So if T is the working temperature and Tm is the melting temperature, if T by Tm value is less than 0.3, then that particular case we have to perform the cold working type of process. Cold working process we have to perform. Okay. Another case is the, like if T by Tm value is between 0.3 and 0.5, if this homologous temperature value is in between 0.3 over the less than 0.3 cold working process, and 0.3 to 0.5, then the process are warm working, warm working. Okay, warm working. So another classification is that how what type of process. Whenever this greater than T by Tm ratio is 0 greater than 0.6, then the process we have to perform is the hot working. Hot working, cold working, warm working, and hot work. I think now hope you understand how you can differentiate this particular what type of process you can choose based on this particular working temperature and melting temperature. So, like if the this T by Tm ratio, that is homologous temperature, is less than 0.3, then the process are cold working. If the T by Tm ratio is in between 0.3 and 0.5, then warm working. If this T by Tm value is greater than 0.6, then the process are the hot working. So this is how you can differentiate this particular thing. What is homologous temperature? The ratio of T by Tm, that is it is a where T is the working temperature and Tm is the melting temperature. Melting temperature. It is a this homologous temperature is a dimensionless quantity. Okay, because if T is the temperature degree centigrade and the melting temperature degree centigrade, both get cancelled. So it is a dimensionless quantity. So that is about that. Is hot working and cold working. Mainly the in the hot working where the T by Tm values are greater than 0.6. Warm working is the T by Tm ratio is 0.3 to 0.5, then warm working. If T by Tm value, that is Tm is the melting temperature and T is the working temperature, then it comes under the cold working processes. Okay. Mainly, like advantages are mainly this hard working is applicable for mass work because you are heating the work material over the recrystallization temperature. Due to that, less forces are required and very suitable for the mass production. And the metal size and shape can be easily you can change, and also this high temperature there is a large deformation is possible. That's why it is suited for the mass production. Compared to the cold working, the deformation amount is high in the case of hot work. That's why it is suited for the mass production. And metal based texture will be refined here because it is forming the new crystals, new strain-free grains of forming during, because you are increase the temperature over the recrystallization temperature. Due to that, the grain refinement is happening here in the hot working, and like whatever residual stresses that are incorporated before that, those stresses can be minimized by using this hot working. And this particular mainly hot working, when compared to cold working, the strength of this particular hot working component is very less, but we can observe the homogeneous properties and homogeneous structure we can observe in this particular hot working type of operations you are performing. And this clearly, when compared to the hard working, this cold working, the ductility property will be good. Okay, and these are very economical process and fast and economical process. And disadvantages, because these processes are costlier one. Okay, because you are need some heating related components that should be there in the connected machine should be there. Due to that, it will increase the initial cost of the equipment. And because during you are heating the material over the recrystallization temperature, is going to develop some oxide layers over the surface. So due to that, you may the surface finish will be not good. It will be very poor when compared to the cold working. So that is the disadvantage. Due to the development of oxide layers, it will reduce the surface finish of the component, and also due to this heating this time sometimes the carbon particles will be left over from the workplace. Due to that, it will reduce the outworking. Due to that, it will reduce the strength of the material. If due to that over temperatures, required temperature you are using, it may cause the loss of carbon particles from the surface. Due to that, it will lead the reduction in the strength of the metal, and also it is difficult to maintain the dimension and accuracy because where there is bulk deformations are there during this hard working. Due to that, sometimes it may not possible to maintain the dimensions properly. So you have to control the temperatures in proper way to maintain the good dimensional accuracies. These are the some disadvantages of this particular our art working of the metals. Mainly, in the next class, I will go through the comparison. That is the differentiation between the what are the different differences of hard working and cold working of the components. After that, I'll go through the two-dimensional stress analysis, and after that, three-dimensional stress analysis and yield criteria things. I'll go through in the next class. Mainly, uh, I gone through the what is like today. I just gone through the this what is the plastic deformation, like mechanisms are there, mainly slipping of one plane of atoms and twinning mechanism. These are causing the plastic deformation. Another one, after that I discuss about the recovery, recrystallization and grain growth. Okay. Mainly during the recovery process, whatever the stresses, local stresses are there, that will be completely relieved during this particular recovery process. And recrystallization, the process in which at a certain temperature range, new and strain-free grains are formed by replacing the older grains. Then we call it as the recrystallization temperature. So whenever you are performing the this particular working temperature over recrystallization temperature, then we will call it as the hot working. And the working temperature plastic, whenever you are performing the plastic deformation of the material below the recrystallization temperature, then it comes under the cold working. Mainly due to the cold working, mainly that when compared to the hard working, the dimensional accuracy will be maintained properly, the hardness will be increased, and the surface finish will be good because there is no oxidation developed over the surface during the cold working of the metals, and strength and wear properties are improved by this cold working type of. But mainly the ductility property may get reduced due to this cold working. Okay, and disadvantages, it leads the because the strength and hardness thing is going to increase. Due to that, it may decrease the ductility property and may cause the brittleness in the work material, and drastically will increase the metal hardness. Sometimes due to that, like due to that, uncontrollable development of hardness in some components, we have to perform heat treatment process like annealing to reduce the hardness. Will perform sometimes because that due to that strain hardening effect, abnormally it will increase the strength. That due to that, sometimes it is required to perform this heat treatment process to decrease again. After that, due to that, it will again increase that production time. All those things will be lead time will get again increase. All these things may happen, and only ductile materials and malleable materials are suitable for this particular cold working. So can't like choose the brittle materials these particular cold working operations, and also greater forces are required because here the working temperature what we are using here is less than the recrystallization temperatures. Due to that, you have to apply the high amount of forces. That's why greater forces are required to have that deformation. So that whenever you require such type of higher forces, your that specifications or equipment capacity, force capacity should be high. Then only it can apply that high amount of forces to attain that deformation. That's why you require powerful machines to attain that greater forces during the deformation process. So these are the different deformations and like hard working old working disadvantage. And after that, I explain about the hard working. Mainly in hard working, the plastic deformation of material is carried out above the recrystallization temperature, and there is one more working, that is the warm working, which lies between the hot working and cold working. So to differentiate all these three, there is one ratio, that is T by Tm ratio, uh, where T is the working temperature and Tm is the melting temperature, which is the ratio of T, this T by Tm, T suffix m, we call it as the homologous temperature. So whenever this homologous temperature value is less than 0.3, then the working process or cold working process. And if the homologous temperature value ranges is in between 0.3 and 0.5, then the process are warm working. In if this the ratio, that homologous temperature ratio is greater than 0.6, then the process are the hot working process. So these are the different this process, and after that I discuss the advantage. Mainly advantages are it will effectively leads to the homogeneous structure of the metal without any defects and blowholes. You can develop the products. And coming to the disadvantages, a costlier process to do this additional heating arrangement, all those things. And sometimes due to the overheating, there is a loss of carbon particles. Due to that, it will lowers the strength of the metal. So these are the disadvantages. Okay. Next, whatever this other topics, comparison and yield criteria, all those things I will explain in the next class. Okay, I request all of you just to present today's Google with questions already that were posted. You just observe this one. In the daily quiz, already I shared the Google quiz. Okay, in the classwork, you click the uh, quiz, daily quiz. Okay, there you can find the post related to the quiz and answer that. Okay. Right. In the last class, also I clearly explained to you regarding this your what type of like different. So already I shared posted today's daily quiz. Okay, in the play section one. So where the students are there, just to submit that one. At that I will take as a even for attendance also will consider same. Till now, 3 students were turned in from the A section. In B section also can observe that the classwork daily quiz, whatever the latest update was there, posted at 12:40, and due time is now 1:15. We have to submit that one. Okay. In 5 students submitted. So coming to the like my earlier whatever like even my earlier class, like at the end of the session, I clearly told that I clearly told I also shared some job responsibilities. Okay, in WhatsApp group also, like So once for that you have to register for the like any this one Naukri.com or any master.com like that. That you have create your own profiles and you just check that and also whatever the requirement you like training is required. Such type of things you have to undergo. Okay. This is the one of the like, job because I posted in your like earlier WhatsApp group. Okay. You can't apply now because this is only for who are the like student they completed the BTech graduation. So here the job is like quality engineer one. Okay. There in that responsibilities are this particular quality standards protocols. Okay. So inspection testing. So such type of knowledge is essential. Mainly production controller. Okay. Product evaluation. Such type of things are required. Okay. So mainly they mention that the employee is also required to interact with the computer and communicate with the peers and co-workers and contact your manager and local HR. So mainly you have to have that communication skills. With that, have to get some knowledge related to the like this uh, quality control related terminology. All those things are related for this, especially for the post like quality engineer. And another one is so one of the jobs they asked related to even the freshers they asked this particular knowledge on the DFM, the design failure mode effect analysis. This type of analysis also they asked in the requirement. So whenever you're having time, you just go through the different job profiles. So what is your goal? What type of job you want to do? Based on that, you can attain that required skills. Maybe the quality supervisor or maybe other different product development engineer like that. Different jobs you can select. So just whatever the like some basic requirements are there. So that type of skills you have to acquire once before applying to the particular jobs. Okay? Here they asked about the job profile, but until whatever the components are there, from gearbox to other driving motors up to the wheels, these are the powertrain components. So nowadays, like different companies, modeling of this powertrains in a simulation software and performing some simulation such time jobs. Even it is a fresher type of this particular job is for freshers, but they asked related to this particular energy. They should the candidate should have the knowledge on energy storage systems and also powertrain components. So that knowledge is essential. Okay, and here also is one of the like job portal. They also they clearly asked and modeling of powertrains. So in the last 10 days, I observed also 3 or 4 companies. They asked related to this, especially powertrain modeling. So if you want to perform, you want to apply such type of job, you need some knowledge related to this power modeling of powertrains, and also nowadays the people, if you should have some knowledge related to MATLAB simulink environment. Okay, that is also because nowadays the people some inter-department knowledge is also required. Okay, for that this MATLAB and Simulink environment package also they are asking. Okay. So you have to model that entire that powertrain model, and after that you have to perform some simulation in the MATLAB Simulink environment. So that is also one of the requirement they ask related to this particular job. The main the thing is as a student that interest and focus is required. So what type of job you want to apply, based on that you have to acquire the skills, because nowadays without the skills companies won't prefer to recruit the this one. Here you can observe clearly they ask for the key responsibilities. Here you can observe the different preparation of less complex engineering deliverables such as drawings. In some earlier this one the students asked what is the need of this CAD software. All those things are the people are not designing, but most of this even manufacturing process planning scheduling also they require the drawings while preparing all these reports. The basic mandatory requirement is for product development. You have to uh, able to use some different CAD packages such a way that you can perform this while preparing reports. You can develop these drawings. That is also one of the requirement. Okay, that's why always you required to learn this different package, maybe Creo or CATIA or Unigraphics or AutoCAD like that. So packages are required. Okay. This is the one of the company sent. So they asked related to this particular mainly skills. Here clearly observe. They asked the CATIA design, CATIA V5. So they during the product development, okay, always you during the product development you require this particular all these CATIA design, CATIA modules you have to required to model that different product related drawings. During product development also it clearly asked here experience in handling 3D and 2D data for modeling and representing of the parts. Okay, maybe modeling and assembly type of module also you have to be idea, and also is a sheet metal casting because to develop, because there will be different wide number of products manufactured, and whenever there is product change, then always they have to design, they have to produce some different molds. That's why the sheet metal and casting, these things also required, that knowledge is required. So that is the case. Okay, no such these CAD softwares are not outdated. Okay, always these whenever the people performing a process planning and scheduling also, these drawing requirements are required. Okay, that's why always clearly is asked experience in handling the 2D and 3D data, and clearly they asked the skill experience. You should have the, even if you are a fresher, they are asking the knowledge about the CATIA design and V5. Okay, that is required. Yeah, they are asking, and also some different calculations we have to perform. That knowledge also required. So like that, so there is no limited one. So whatever till now we've seen that some MATLAB Simulink software is required, or maybe some CATIA platform is required. So based on the type of job, it may change. So So what is your goal? What type of job you want to attain? Based on that, you have to get training that with respect to software. Okay, maybe simulation softwares or AutoCAD or maybe some other different quality tool, quality control techniques are there. Those things you have to learn. Okay. Here we can clearly observe that one of the job it's already explained regarding sent. They ask the criteria requirement, one of the requirement for that, and also here one of the company like they are related to chassis equipment. Here and require the knowledge about the material requirement planning softwares. Essential qualifications they ask for like experience in product development. So always if you need some any product development experiences, for that you need some like modeling softwares, maybe a different modeling package or assembly package related to CATIA or unique graphics. That type of knowledge they are most of the companies they are asking, and also like different routing like process planning related softwares are there. That type of knowledge also they are asking. Okay. These are the essential requirements. Product development. Okay. Hope I think you understand about the what are the like companies requirements are there. So only the interest that you have to show to attain all these knowledge. Like I like till now I asked about this particular DFMEA. Okay, just go through the website. There are a lot of YouTube videos are there. Okay, like design failure mode effect analysis, because once you develop the product at the end stage, if you are identifying the failure, then again because nowadays different companies like Maruti or other, even here, Kia also they recall some 100 or 1,000 cars because they identify some failure. Always like during the product, if you are identifying the failure during the initial stages of the product development, they can such type of heavy investment that are you are investing on the during the your initial once you release the product and warranty over warranty the companies are giving so much amount to the customers, then that is a loss to the company. So for that, always there is a requirement to identify the failure at the design itself. That particular analysis is the design failure mode and effect analysis. Now most of the companies they are even nowadays they are seeing for this. So whatever the I like one of the Benz or Volvo company I shown some requirement. So they entirely they are doing this DFMEA, that is a design failure mode effect analysis. So just that knowledge learning trust is required by you. You don't have the trust, okay? Then nobody can learn this one. Just wasting your time on some other activities. So whenever you have some time, then just you concentrate and be focused and choose the appropriate requirement. Most of the cases, the product development requirement is one of the important one, and also these simulation related software also how to learn. Okay. So regarding this today's answers, I'll just go through the answers. Because now you people are in 1 month or 2 months, you will promote to the 4-1. Then there is no time for you. So always all these things you have to learn before you are leaving the campus. Okay. Once again after leaving the campus, after that you are learning all these courses. Again, you will 1 or 2 years of time you are going to waste on it. Okay. The first question for today's quiz is related to the cold working of metal is accomplished at a dash. So the answer is we know that below the recrystallization temperature, the cold working of metal is accomplished. The first one answer is B, that is below recrystallization temperature. The process of formation of new grains is known as recrystallization. The answer is B. In deformation by slip, the deformation of metal takes place along the dash. That is slip plane. The deformation of metal takes place along the slip plane. That is answer is C for third question. And fourth one, good surface finish and better emission accuracy can be achieved, because we have clearly told that especially in cold working process we can attain good surface finish and better emission accuracy. For fourth one, the answer is the A, cold working process. The last one, that is the plastic deformation of metal takes place when stress induced in the metal due to the upward forces is reached to the, that clearly shows that plastic deformation, you can say that whenever the stress point reaches to the yield point, then we can say that the metal will subjected to the plastic deformation. So answer is the yield point. The plastic deformation of metal takes place when stress induced in the metal due to the applied forces reaches to the yield point, then will be subject to the plastic deformation. The answer is the A. That's it for today. You can have having any doubts or any thing you want to talk, you can unmute and you can talk. Otherwise, you can leave the class.